All right, so one way that you can graph something that's in standard form is to just straight up convert it to slope-intercept form. Like this one would be very easy to convert. All you would have to do is plus 3x on both sides, and you get y equals 3x minus 9. All right, that's a super important technique. You're going to want to be well-versed in how to do that fluently. So I'd recommend go ahead and try that on these as well. But what we're going to do in this video is look at another technique for graphing these, and it's just by getting the x and y intercepts. All right, because those were pretty easy things to do as well. Uh, if we find our x-intercept by plugging in 0 for y, we're going to get negative 3x equals negative 9. So the x-intercept is positive 3. Okay. Our y-intercept, remember we plug in 0 for x to do that, and so that's just leaving us with y equals negative 9. But we could use this to sketch a graph, a general graph of what the function is going to look like. These are like the two hotspots. All right, negative 9 is our y-intercept. So that means it's going to cross down here at negative 9. And then our x-intercept is positive 3, which is about right here. And you can use those 2 points to draw your graph. There's a couple of downfalls for using this method, but it is a very quick way rather than converting it to this form and then graphing. One of the issues is when the x-intercept or the y-intercept is a fraction. That kind of makes things look ugly. And then the last issue, I'll show you on our last example here. All right, let me do a couple more of these. For the x-intercept, we're going to plug in, well, here, let me do it. For the x-intercept, we'll plug in 0 for y. So I get 4x equals 12. Divide by 4, x is equal to 3. All right, x equal 3 is about right there. And then for the y-intercept, we'll plug in 0 for x. So 2y equals 12. So y is equal to positive 6, which is up here somewhere. There we go. So this one has negative slope. Finally, one with negative slope. Cool. Right. For our x-intercept, we will do 0 for this y. So that's going to leave us with negative x equals positive 10. Divide by negative 1, and you'll get x equals negative 10. This is also another issue with graphing them this way. Sometimes you don't have room on your picture to plot your x-intercept. Like your x-intercept could be way out here to negative 30, something like that. Our y-intercept, plug in 0 for that. You get 5y equals 10. So y is equal to positive 2, which is about right there. Okay. All right, this one right here, this is going to be one of those situations where you have to, you have to convert it to slope-intercept form. Because if you look here, your x-intercept, you would just divide by 2, and you would get 0. And then for your y-intercept, you're also going to get 0 here. And that doesn't tell us which way to go with the line. Like we don't know if we're going uphill or downhill. We can't tell from this. All we know is that the x and y intercept are both 0. So you would have to convert it. You'd have to solve for y in situations where the c term is 0. All right, not too bad. We'll just subtract 2x from both sides. 3y is equal to negative 2x. We'll divide by 3. So y is equal to negative 2/3 x. Remember, the way we graph these is we would start off at 0, and then we would use our slope. Down 2 units, over 3. Up 2, left 3. Okay? So there's advantages. Speed is one advantage. It's very quick once you're handy with this. It's very quick to just plot the x and the y intercepts and base your answer off of that. But sometimes you see like this, it's absolutely necessary to convert it to y equal mx plus b form.